We're now at question 6 of our complex number exercise. You have 5 minus 7i raised to the power of 6. What did you get for it when you worked it out? Alright, let's see something here. Certainly, you don't want to try to have 6 different 5 minus 7i and multiply them all out. Right? In this case, you have no choice but to use the Mohr theorem. You remember what the theorem says? It says if you have z, complex number z is equal to you have r cos theta plus I r sine theta, then z to the power of n is equal to r to the power of n cos n theta plus I r to the power of n sine n theta. Alright, you remember that? Now, what it means is that we're going to have to convert this thing to polar form. So, we do that. We have our x-axis and our y-axis, and we want to visualize a complex number. So, say 5. Oh, I should write the x-axis a bit up more, right? This is what I'm seeing here. So, what we have? We go out 5 minus 7, I mean we go down 7. So, there we have that. This part is below 5 and beside negative 7. Now, here we're going to find the absolute value of the complex number, which is r, and we have to find the angle. Remember, the angle is measured from the positive x-axis of the x-axis in an anti-clockwise direction. We go all the way around here to find our theta. Alright? Now, let's call this angle here alpha. If we redraw this thing, we get something like this. This is alpha, and this is 5 right angle triangle and 7. This is our right angle triangle here. So, here now, we're going to find alpha and r. We use our knowledge of trigonometry to do that. Alright? So, tan alpha is equal to, well, it would be the opposite 7 over adjacent 5. So, therefore, alpha is going to be tan inverse of 7 over 5. Tan inverse 7 over 5 with a calculator. What do you get? 7 over 5 equal 1.4. When you tan invert that, you get 54.46. Yeah. So 54.462 degrees. I'm just keeping it to 3 decimal places while working it out. Alright? So, that is the angle that we get here. But we want theta. So the angle theta is going to be 54.462. Oh, I should write the 360 degree because here, what happens is that we go 360 degrees and then take back the 54 point odd off the 360. So, therefore, theta is 360 minus 54.462 equal, what do you get for that? 305.54 or 305.54. So we get 305.54 degrees. So we get our alpha equal 305.54 degrees. See that? What about R? What did you get for R when you work it out? We have 5 and 7. So R squared equal to 5 squared plus 7 squared, which is 5 squared is 25 plus 7, 7, 49. 25 and 49 is 74. So R would be the square root of 74, which is what? Square root of 74. 8.6. So you get 8.6, alright? So our R is equal to 8.6 units long. So what we have is that our complex number here, Z, is equal to 8.6 cos 305.54 degrees plus, we're going to have to erase some of the working we have over here to make space, plus I on the I-axis, 8.6 sine 305.54 degrees. You see that? Now, that means Z to the power of 6 is equal to 8.6 to the 6 cos 305.54 times 6 plus, and then I 8.6 to the power of 6 sine 305.54 times 6. So, what do we get? Z to the 6 is equal to, we have 8.6 to the power of 6. You remember how to write or find a number to a power in a calculator? You have x to the y on some calculators. X to the y, so you press 8.6, press this button and then 6. Some calculators have this, right, for you to press. So, what we would have? Some big numbers here. 404,567, 404,567 cos, and then the 305.54 times 6 would give us 1833.24, 1833.24 plus I times the 404,567, 404,567 sine 1833.24, right? So that's the polar form. Let's convert it back now to rectangular form. So z squared is equal to, so what you need to do is say 404,567 multiplied by the cos of 1833.24. I get 338,372. So it's 338,372, big numbers here, plus I and then you have your 404, 567, times the sine of 1833.24. If you sine that, multiply, you get 221,762. So you have 221,762. So that is what you have when you work it out. Z square is equal to, not Z square. What did I put Z square for? It's Z to the power of 6. So Z to the 6 equal that. So that is your answer.